Hey guys, I'm Tony Tian, and if you're new to this channel, I'm a second-year medical student at University of Otago. So today, what we're gonna be talking about is the histological feature of the stomach. So instead of thinking it as histological, just think about as the microscopic features of the stomach, and I'm gonna link it into some of the physiology of the stomach as well. And if we had time, we might move on to some other parts as well. Okay, cool. So let's talk about the basic four layers of the gut wall. If you guys still remember, so you usually have the mucosa layer. The mucosa layers consist of the epithelium, the lamina propria, and the muscularis mucosa, and then below the muscularis mucosa you have the submucosa, which contains the submucosal plexus, which is a nerve plexus. And sometimes in the submucosa you have the submucosal glands, and it's only present in two places, which is your esophagus and the duodenum of your small intestine. And then below the submucosa, actually more exterior to the submucosa, we have the Muscularis Externa or Muscularis propria.
Go ahead.
That scared me, and that was my Siri. Just ignore that. Okay. And the Muscularis Externa usually contains two layers, which is a circular layer and a longitudinal layer. The circular is more inner and the longitudinal is the outer layer. But in stomach, it's a little bit special. You have an extra layer due to the motility of the stomach, which is a extra more in the innermost oblique layer, and the circular layer become the middle one. Okay. And in between the circular layer and the longitudinal layer, you have this nerve plexus called the Menteric Plexus. And at the very outside, you have the adventitia, and that's the four layers. Alright, so now we're gonna dive deep into the stomach, some of the specific feature of the stomach. So before we start, we're gonna talk about some of the gross anatomy features. So in your stomach, you have four parts: the cardia, the fundus, the body, and the pylorus. Alright, and between the cardia and the pylorus, you have this two if you can sort of imagine the shape of the stomach, there's a lesser curvature and there's a greater curvature on the other side. So basically, the greater curvature is where the stomach expands a little more and has this feature called a rugae. Basically, it's like a fold that's on the stomach, and it's this expandable structure of the mucosa. And basically, when you eat a lot of foods, the rugae is able to expand out, so your stomach can store more food, and it's more abundant on the greater curvature side, because the lesser curvature is attached to the liver, and because of the liver position, the lesser curvature can't really expand much, but the greater curvature can sort of just push out to the skin. Alright, and on the lesser curvature side, you have the presence of something called a gastric nail. So basically, if you imagine rugae, but it's sort of in a longitudinal direction, so it's sort of directing all the liquid from the cardia straight into the pylorus. And this is because as fluid, they don't need the mechanical digestion. They don't need all those mixing, all of that, because the liquid itself is already mixed, so it doesn't really need any mechanical digestion, and it can just go straight in the duodenum for absorption. All right, cool. So now let's talk about the more microscopic kind of features. So for the mucosa, first of all, the epithelium glands, you have the simple columnar epithelium, and this is because you need to secrete in the stomach, and versus like in the early part of the esophagus, you just need to get the food in. All right, and then for the lamina propria of the stomach, it has something really special. It has a lot of blood vessels present in this layer, and it's very specific to stomach. And this is because when you're producing the chloric acid, the hydrochloric acid, in your stomach, you are producing a lot of bicarbonate as a byproduct, because the way we produce acid is sort of you're combining the H2O, the water molecule, with the carbon dioxide molecule, and then you then redivide it into a hydronium ion and a hydrogen ion and a bicarbonate anion, and this anion needs to be get rid of because the hydrogen ion, the cation is going out into the lumen of the stomach, and if you don't, you're just going to get an accumulation of the bicarbonate inside of the cell, and it's going to get very basic, which is not good. So you need to get rid of that, and to get rid of that, you need blood flow to wash it away. All right. And then you have the periglandular vascular plexus in between, and then under there you have the muscularis mucosa, which squeezes the glands. It squeezes all the glands that secrete acid and other kinds of digestive enzymes into the lumen, and it has 2 layers of smooth muscle, but it's not really differentiable. When you're looking at it, it's not like the Muscularis Externa that have pretty distinct muscle layers. Okay, and then you have the submucosa, which contains the arterial anastomosis. Basically, it just means there are arteries building up, and the venous plexus. And you have the submucosal nerve plexus, as I mentioned, as all of the gut wall. Okay, and then we move on to the Muscularis External, which has 3 layers: the inner oblique, and the middle is circular, and the outer longitudinal. And basically depends on their function. They are sort of in different parts. So for example, for the middle circular layer, it's more, because it's circular, and if you think about circular, it's more functional when it's at the sphincters. So it is more abundant at the pyloric sphincter near the duodenum. Duodenum is the first segment of the small intestine. And then you have the longitudinal layer, which is more in the upper part for that mechanical squeeze and mixing. And then you have the inner oblique, which is its major function, just an additional layer for churning. So just sort of imagine an extra force to sort of mix the food in different direction. And then you have the adventitia and the serosa, which has large blood vessels and osmosis. Okay, so now let's talk about the gastric mucosa and some of the very specific features about it. So as I mentioned, it's a simple columnar epithelium, and the epithelium invaginates into the lamina propria to form gastric pit and gastric glands. And the gastric glands have a neck, an isthmus part, a body, and a base. And basically, remember, all the glands in stomach are mucosal glands. They don't go into the submucosa, so they're above the muscularis mucosa. And the lamina propria supports these glands, and they are highly vascular. And the muscularis mucosa separate the mucosa and the submucosa. Alright, so hope you guys have a general understanding about the gastric features and some of the basic gross anatomy structure, and also some of the more microscopic ones. And in the next video, we're gonna dive deep into the specific glands that is in your stomach. And so if you're interested in that, just keep yourself subscribed and hit the like button. And if you have any questions, just leave it in the comment section below, and I'll see you next time. Bye.